Welcome to the FluidSim video tutorials. This video describes the GraphSet PLC. These are the topics. Function of the GraphSet PLC. Properties of the GraphSet PLC. Example magazine, GraphSet. Example of a real magazine, electrical circuit diagram. Example of a real magazine simulation. GraphSet. Control of component parameters. The GraphSet PLC. The GraphSet PLC component is a control device based on a PLC. The GraphSet PLC requires a power supply of 24 volts. The inputs and outputs are binary. Input voltages less than or equal to 17 volts are interpreted as a low signal and greater than 17 volts are interpreted as a high signal. The outputs show 0 volts for low and 24 volts for high. The GraphSet PLC has no analog inputs and outputs. The GraphSet PLC cannot be expanded. For this reason there is GraphSet PLC with 8, 16 or 32 inputs and outputs. Properties of the GraphSet PLC using the magazine as an example. A GraphSet PLC was already used in the project magazine of the GraphSet video. A GraphSet PLC with 8 inputs and outputs was inserted from the library. The project contains 3 sheets for the pneumatic and electrical circuit diagram as well as for the GraphSet plan. If GraphSet PLC and GraphSet are on the same sheet, GraphSet is automatically assigned to GraphSet PLC. In the magazine example, the GraphSet is on the GraphSet sheet. The Properties dialog is started by double-clicking the GraphSet PLC symbol. In the drop-down menu, Associated Sheets, the sheet that contains the GraphSet is selected. Symbolic operands can be entered in the Inputs and Outputs section. In the example, the button SF1 and the end position sensors BG1 and BG2 form the inputs and the coil MB1 the output. The symbolic operands are the variables of the assigned GraphSet. The electrical circuit diagram is now complete. Example magazine, GraphSet. The GraphSet describes the process for separating workpieces. After the initial step, the extension transition contains the start condition. The transition is fulfilled when the cylinder is retracted and the start button SF1 has been pressed. In step 2, the coil of the monostable solenoid valve is activated as long as step 2 is active. This is achieved with a simple action that includes as a variable MB1. Step 2 can only be exited when the cylinder is extended and the transition waiting time has expired. The signal from the end position sensor BG2 must be active for 3 seconds before the transition condition is met. This can be observed in the simulation. A displacement time diagram of the cylinder can be added for better illustration. The GraphSet PLC will be replaced directly by a real PLC when it is implemented in practice. The GraphSet is then the basis for developing the PLC program. Example magazine, FluidSim controls the real magazine with the GraphSet. The following example shows the connection between hardware and software. With the EasyPort USB interface from Festo Didactic, the GraphSet can also take on the role of the real controller in FluidSim. In the electrical circuit, the virtual sensors and actuators are replaced by the FluidSim in/out interfaces. The magazine module from Festo Didactic is suitable for our example. The module can be connected directly to the EasyPort using the Syslink cable. The correct inputs of the EasyPort must now be connected to the GraphSet PLC in FluidSim. To do this, the FluidSim in symbol is dragged from the library onto the drawing area and connected to the GraphSet PLC. FluidSim out is connected to the GraphSet PLC for the output side. The assignment of the connections is taken from the technical documentation of the model. Example magazine simulation. The simulation is started to test the model and the GraphSet. For easier operation, the start button SF1 has been linked to the green button of a wireless Xbox controller. The BG1 sensor is active because the cylinder is retracted. If you press the green button on the Xbox controller, Step 2 of the graph set becomes active. In the action of Step 2, the coil MB1 is activated. The cylinder MM1 then extends. The sensor BG2 becomes active. If the cylinder is extended for 3 seconds, Step 2 is exited and the cylinder retracts. This has reached the basic position and the process can be started again. The circuit is represented by the GraphSet PLC in accordance with the standard. The GraphSet PLC can only process binary signals and the GraphSet variables only have an internal effect. Component variables cannot be processed with the GraphSet PLC. GraphSet – control of component parameters. Component variables can be processed reading in Graph View mode. In Graph Control mode, component parameters can be read and changed. This means that analog signals can also be processed in the GraphSet. The following example shows the setting of a potentiometer using the GraphSet. Different output voltages are set time-controlled with the voltage divider. In the GraphSet, the variable of the potentiometer position is assigned a value between 0 and 100. This changes the output voltage of the voltage divider. The output voltage is recorded with a voltmeter. The voltage measured by the measuring device is compared with a limit value in the GraphSet. In the example, a signal lamp is switched on for voltages greater than 5 volts. The evaluation of measurement signals enables control-related relationships to be mapped with the GraphSet. Thank you for your attention.